Question number 6 about inverse functions. Find f inverse of x. You first move, remember, inverse functions exchange x and y. So I'm going to rewrite the expression of f of x, but instead of x, I'm going to put y. 3 times base 2 of y minus 5 minus 5. And we'll set that equals to x. Because I want to solve that for y, that's going to be the next step, make sure you do it that way, because that way the variable that you want to isolate is on the left. It's not essential, but it is important to make things easier for you. So let me first isolate the base 2 of y minus 5 and have x plus 5 divided by 3. And therefore, y minus 5, let me cross over the base 2. The inverse of base 2 is log 2. And finally, I'm going to cross over that subtraction of 5, and I'll have log 2 of x plus 5 over 3 plus 5. Now, graphing all of that. So first, I'm being asked to graph f of x. So you need to identify h, which is positive 5, and k, which is negative 5. 5, negative 5, right here. It is an exponential function. So here is my horizontal asymptote. A is 3. So from that new point of reference, I'm going to count 3 up because it is a positive. Then every time that I'm going to go 1 unit to the right, I'm going to multiply that distance from the asymptote by 2. And 3 times 2 is 6. Times 2 is 12, see? So 1, 2, 3, 4, 5, 6. So it's going to be here. But if I go the other way, if I subtract 1, I'm going to divide by the base. And 3 divided by 2 is 1.5. Divided by 2 is 0.75. And that will give me something like that. Then I'm going to graph x, y equals x, as a dotted line. Why is it important? It's because both functions are going to reflect from each other across that line. That's the line y equals x. At first, this one here is y equals f of x. And let's put that in green. To construct this, oh, and by the way, I forgot something essential. I did all the work, but I forgot to conclude. The question A is find f inverse of x. So my last line should be the answer. F inverse of x equals log 2 of x plus 5 over 3 plus 5. Otherwise, you know that Mr. Dimale is going to take points off. All right. Now, the easiest way to graph this is to swap the x and y coordinates of the function. And the point of reference, which is 5, -5, is going to become -5, 5. I just switch them. Vertical asymptote for a logarithmic function. And here you cannot just go 1 unit to the right of this point of reference because the coefficient of x is 1/3, not a 1, as we did for the transformation before. So what I'm going to do instead, I'm going to take every point. This one is 5, -2. It's going to become -2, 5. This one is 6, 1. So I'm going to go 1, 6. This one is 7, 7. So it's going to be 7, 7. This one here is 3, -4.25. So -4.25, 3 is going to be here. And that's already enough to give me a decent graph. This is y equals f inverse of x. Now you can always check your answers at your graph. If I punch that in, log base 2, so alpha window 5, base 2 of, so here I'll have a fraction, x plus 5 on top, divided by 3, and outside plus 5. And if I graph it, let me give you the large display. You can see that it fits. Now you can have the square zoom. So it's zoom 5. It will look a little bit more like the graph. If you type for y2 3 times base 2 of x minus 5 minus 5, you graph this whole thing, you have it, see? And you can also eventually use second graph to get the table and have specific value for both. That's it. Good luck.